Hi friends, welcome back to another video. So today I'll be explaining physics May-June 2018 paper 42. Also, I would like to tell you guys that more than 95% aren't subscribed, so make sure to subscribe and turn on post notifications. Question 1a states figure 1.1 shows the axis of the distance time graph for an object moving in a straight line. So this is a distance time graph, and in part 1 states on figure 1.1 draw between time 0 and time is equal to 10 seconds the graph for an object moving with a constant speed of 5 meters per second. Start your graph at distance 0 meters. So over here at 0 it is at 0 meters, and then at 2 seconds it is at 10 meters because 2 times 5 is 2 times 5 meter per second is 10 meters per 10 meters, and then at 4 it is at 20, whereas at 6 it is at 30, and at 8 it is at 40, and at 10 seconds it is at 50 meters. So we will plot these all points and then draw a straight uniform line from 0 till 50 over here. Then two states state the property of the graph that represents the speed. It is a gradient or a slope from 0 0 to 10 50. Then part 2 states between time is equal to 10 seconds and 20 seconds the object accelerates. The speed time graph is equal to 20 seconds is 9 meters per second. Calculate the average acceleration between time 10 seconds and time 20 seconds. So the acceleration is equal to change in velocity divided by change in time. So change in velocity is new speed minus old speed, which is 9 minus 5, divided by new time minus old time, which is 20 minus 10, which will be 4 divided by 10, and the acceleration is 0.4 meters per second squared. Then so the acceleration or the final answer for part 2 is 0.4 meters per second square, and it is important to put the unit in which you are measuring the answer. So we will write 0.4 meter per second squared. Question B states figure 1.2 shows the axis of a speed time graph for a different object. The object has an initial speed of 50 meters per second and uniformly decelerates for 0.35 meters per second for 100 seconds. On the figure 1.2, draw the graph to represent the motion of the object. So here we have the change in time, which is 100 seconds, because from 0 to 100 is 100 seconds. So we will use the formula of acceleration, which is a is equal to change in speed or velocity divided by change in time. So over here the change in time is 100, so we write change in velocity, which is 50 minus x, is equal to acceleration, which is 0.35 meter per second, 0.35 meter per second. So when we move this to there, it will be 50 minus x is equal to 35, and value of x is 50 minus 35, which will be 15 meter per second. So the final velocity of the object after at 100 seconds will be 15 meter per second. So we will plot the point and connect it from 0 50 till 100 to ratio of 15. So this will be the line from here till here. Then part 2 state calculate the distance traveled by the object from time 0 to time 100 seconds. So first you can see this is a trapezium. We have to calculate the area below the graph, not above the graph. So below the graph it is a trapezium, so we break down is this trapezium into two parts, which will be a rectangle and a triangle. So first we will calculate the area of rectangle, which is area is equal to L times width, which is 100 multiplied by 15, and that is 1500 meters squared. Then area 2 will be the area of triangle, so the height is 15 minus 15, 50 minus 15, which will be 35, and the base length is 100. So 35 multiplied by 100 divided by 2 will be 1750. So when we add 1750 to 1500, it will be 3250, but you have to write this in two significant figures. So this will be 3300 meters. So the distance of travel by the object from time 0 to time 100 second will be 3300 meters. Question 2 states figure 2.1 shows a hollow metal cylinder containing air floating in the sea. So calculate the density of the metal used to make the cylinder is greater than the density. The density of the metal used to make the cylinder is greater than the density of the seawater. Explain why the cylinder floats. So the combined density of the metal and air contained is less than the density of the seawater. So that's why the metal cylinder is floating on the surface of the sea. Then part B states the cylinder has a length of 1.8 meters. It floats with 1.2 submerged in the sea. The bottom of the cylinder has an area of cross-sectional of 0.8 meters. The density of the seawater is 1020 kilograms per meter cubed. Calculate the force exerted on the bottom of the cylinder due to the depth of the seawater. So first we will calculate the pressure, which is pressure is equal to height times pressure multiplied by gravitational force. So 1.2 multiplied by the pressure, which is P is the density. Just told something wrong. So P is the density, which is 1020 multiplied by the gravitational force, which is 10. So the value is 12,240 pascals. Then we will calculate the pressure or the force of exerted on the bottom of the cylinder, because we have the value of the area. It floats with a 1.2 meter submerged in the sea area. Here we have 1.2 meter float in the sea, and the area of the cross section is 0.8. So we will use 0.8 as the area of the cylinder cross section, and we will use the pressure, which we have already calculated, which is 12,240. So pressure is equal to force divided by area, and then force is equal to pressure times area. So 12,240 multiplied by 0.8, which will be 9792 newtons. So as in whole paper, we have to calculate the values in two significant figures, so it will be 9800 newtons. So the force will be 9800, and or you can write newtons. Then part C states deduce the weight of the cylinder. Explain your answer. The weight is 9800. Explanation: the resultant force is equal to 0 because the downward force is equal to the upward force. Because if it's not equal, the cylinder will move up or float in the sea, whereas it's equal, so it is submerged to the bottom of the seawater. So this is how we will write. Weight is 9800 newtons. Weight is 9800, and explanation is the resultant force is equal to 0 because the downward force is equal to upward force. Question 3 states figure 3.1 shows an aircraft on the deck of an aircraft carrier. The aircraft accelerates from rest along the deck at takeoff. The aircraft has a speed of 75 meters per second, and the mass of aircraft is 9500 kilograms. Calculate the kinetic energy of the aircraft at takeoff. So kinetic energy formula is Ke is equal to 1 over 2 multiplied by mass multiplied by velocity squared, v squared. So 1 over 2 multiplied by 9500 multiplied by 75 squared, which will be 2.7 multiplied by 10 to the power of 7 joules. So this will be the final answer for kinetic energy for question A. Then question B states on an aircraft carrier, a catapult provides an accelerating force on the aircraft. The catapult provides a constant force for a distance of 150 meters along the deck. Calculate the resultant force on the aircraft as it accelerates. Assume that all the kinetic energy at takeoff is from the work done on the aircraft by the catapult. So the kinetic energy is equal to force times length, whereas we don't have the value of force, but we have the length and kinetic energy values. So instead of writing Ke is equal to force to multiply by length, we will write force is equal to Ke divided by length, which is 2.7 multiplied by 10 to the power of 7 divided by 150. And this will be 118,000 newtons, which will be 1.8 multiplied by 10 to the power of 5 newtons. So the force is 1.8 multiplied by 10 to the power of 5 newtons, as this will be the final answer for part B. So we will write this as final answer. Question 4a states figure 4.1 represents an atom. representing atoms by circles approximately the same size as in figure 4.1 sketch. So in part 1 on figure 4.2, the arrangement of atoms in crystalline solid. So over here in solid, all the particles are really close to each other. So this is how we will draw the arrangement of atoms in solid. Whereas in part 2, figure 4.3, the arrangement of atoms in a gas. So over here in gas, particles are far away from each other. So this is how we will make atoms in gas in figure 4.3. Then part B, part 1 states describe the motion of atoms in solid. In solids, atoms vibrate about fixed position. So this is what we will write in part 1. And in part 2, a sculptor makes a statue from a block of crystalline rock using the cutting tool. Explain why he must apply a large force to the tool to remove a small piece of rock. Force applied must be large enough to overcome forces between the atoms in the rock. So this is the answer that must be written in part 2. Then in part C, a helium-filled balloon in the room of a house suddenly burst. State and explain in terms of atom what happened to the helium from the balloon after the balloon has burst. So atoms will move freely and collide with air molecules. They will move randomly at high speed, and as helium has low density, so it will rise. So since you can write either atoms will move freely and collide with air molecules, they will move randomly at high speed, or else you can write they will move randomly at high speed, or the helium has a low density, so it will rise in air. So this is what we will write in part C. Question 5 states a student wants to investigate good and bad absorbers of thermal radiation. She has the apparatus shown in figure 5.1, a supply of cold water and the meter rule. So she has a small polished can, a small black painted can, 2 thermometer and electric heater. Explain how the student could use the apparatus she has available to carry out her investigation. Describe the result she would expect to obtain. Draw a diagram of the setup. So first we will draw a black painted can and a polished can at the same distance from the electric heater and the thermometer in both of the cans. Then the explanation will be: place the thermometer in water and measure the initial temperature to ensure they are same. Place the gas at similar distance from the heater and turn it on. Ensure the volume of the water in both cans is similar. After a while, the result is that the black painted can will have a higher temperature reading because it is a good absorber of thermal radiation than a polished can, and it will have less amount of water remaining as compared to the polished can. So this is what we will write in question 5. Question 6a states circle 2 of the following that applies to an ultrasound wave traveling in air. So we have frequency 3.5 Hz, which is wrong. Then second is frequency 350 Hz, which is also wrong. Whereas frequency 35,000 Hz, which is correct because it applied to an ultrasound wave traveling in air. Then it is a longitudinal wave. Yes, this is correct. But it's not transverse waves, and the speed is not 1.5 meters per second, and also the speed is not 1.5 multiplied by 10 to the power of 3 meters per second. And last, it's not speed multiplied by 1.5 multiplied by 10 to the power of 8 meters per second. So it is the only correct answer. 2 of the correct answer is frequency 35,000 Hz and longitudinal waves. Then part B states calculate the wavelength in vacuum of X-rays of frequency 1.3 multiplied by 10 to the power of 17 Hz. So the wavelength is V is equal to frequency multiplied by wavelength. So wavelength is equal to 3 multiplied by 10 to the power of 3 divided by 1.3 multiplied by 10 to the power of 17, which will be 2.3 multiplied by 10 to the power of 9. So the wavelength is 2.3 multiplied by 10 to the power of 9 meter. So this is what we will write as the final answer for question C. Then Question B. Then in question C, a dentist takes an X-ray photograph of a patient's teeth. Explain why it is safe for the patient to be close to the surface of X-rays, but the dentist must stand away from the source. X-rays are harmful to humans. It is safe for patient to be close as he is rarely exposed to it. The doctor is exposed multiple times during the day, so it is harmful. So this is what we will write in question C as the answer. Then in question D, state a reason why microwave ovens are designed only to work with the door closed. Microwaves are dangerous to humans. A closed door ensures that no rays pass through if the door was open. So this is what we will write in part D of question 6. Question 7a states a figure shows a ray of light in water that is incident on a submerged transparent plastic block. State what happens to the speed of the light as it enters the plastic block. Explain your answer. So once the light ray enters the plastic block, the speed of the light decreases because the refractive index is less than 1, so it bends towards the normal. So the normal line over here is like this. So if for example it is 50 degree over here, then over here it will be 20 degree because the refractive index is less than 1, so it bends towards the normal. Then part B states figure 7.2 shows the two principal focuses f1 and f2 of the thin converging lens. Figure 7.2 also shows an object of height 1.2 placed close to the lens. Two rays from the tip of the object O are incident on the lens. So over here on part 1, figure 7.2 continue the paths of these two rays for further distances of at least 5 cm. So we have to continue the path of two rays. Over here we have first ray, which over here it bends and passes through the f2, and the first ray over here it passes through the middle of the through the base of the line of the surface and through the lens. So it continues straight over here, and these are the two lines. Then over here it states using your answer to P1, find and mark on the 7.2 the image I of the object O and label the image. So we will also extend this line backwards from here from object O towards the left, and when these two lines intersect, they intersect at this point. So this is the point where the image I will be formed. So we will mark the image I and label the image. So this will be the image. Then part 3 states determine the height of image I. So the height is 3.1 centimeter, which will be calculated using the ruler, and so this will 3.1 centimeter will be the final height of the image I. Then part 4 states state and explain whether I is a real image or a visual image. It is a visual image as the light does not pass through the image onto the screen because it is formed behind the object, not in the opposite direction of the object. So this is what we will write in part 4 of question 7. Question 8 states figure 8.1 shows a circuit that contains a battery of electromotive force 6 volts, an ammeter, a 20 ohm resistor, and a component X. So state the variable component X, which is a variable resistor or a rheostat. Then part 2 states the potential difference across the 20 ohm resistor is measured with the voltmeter. On figure 8.1, draw the symbol of the voltmeter connected to the circuit. So over here, part 2 states the potential difference across the 20 ohm resistor is measured with the voltmeter across the 20 ohm resistor. So it will be from here a separate line will be drawn, and over here a voltmeter will be connected, which is labeled as V. So this is what we will write in part 2. Then in question B, the PD across 20 ohm resistor is varied from 0 to 6 volt. For each value of PD, a corresponding current is measured. So then over here, draw a line to indicate how the current measured by the ammeter depends across the 20 ohm resistor. So at 1 volt it is 0.5 because 1 divided by 20 is 0.5. Then at 2 it is at 0.1 amps. Then at 3 it is at 0.15, whereas at 4 it is at 0.2, and then at 5 it is at 0.25, whereas at 6 it is at 0.3. So this is what we'll draw a straight line from 0 till 6 volts and 0.3 amps of current. Then part C states a second resistor is connected with the circuit into the circuit in parallel with the 20 ohm resistor. State how the combined resistance of the two resistors in parallel compares with the resistance of each of the resistor on its own. The combined resistance is less than the resistance of either resistor. So this is what we'll write in part C of part 1. Then part 2 states the PD across the two parallel resistors is changed and the current in the battery for each value of PD is measured. A second line could be drawn on figure 8.2 to indicate the current measured by the ammeter depends on the PD across the two resistors in parallel. State how the second line differs from the original line. You are not expected to draw this second line. So the second line will be steeper from the original line and there will be a greater gradient because as the resistors are changed, so more current will be flowing through the transferring from through the circuit, so it will be steeper from the original line and there will be a greater gradient. So this is what we'll write in part 2 of question 8. Question 9a states figure 9.1 shows a coil ABCD with two turns. The coil in a magnetic field. So when there is a current in the coil experiences a turning effect. Explain why there is a turning effect. So the turning effect is caused by the forces on A, B and CD in opposite direction. So when over here, if at North Pole and close North Pole, if BA is North Pole, this will reflect and BA will turn into South Pole, and then over here it will be again deflected from South Pole and it will move towards the North Pole. So this will continue many times. So this is why the turning effect is caused by the forces on A, B and CD in opposite direction. Then part 2 states the value of the current is 3 amps. Place one tick in each of the column of the table to indicate how the turning effect changes with the change described. Number of turns on coil increased to 6. So the turning effect is increased by a factor of 3. Then current is increased to 9 amps. So it is increased by a factor of 3. Whereas the strength of the magnetic field decreased by a factor of 2. So there will be a decrease by a factor of 2. So this is what we will do. If we increase the number of coils by 6, it will increase by a factor of 3, whereas increase of current to 9 amps, it will be increased by a factor of 3, whereas the strength of magnetic field decreased by a factor of 2, so this will also be decreased by a factor of 2. So this is what we will write in part 2 of 9a. Then part B states show a magnet held, and figure 9.2 shows a magnet held just below a vertical coil connected to the galvanometer. The magnet is released. State any effect on the galvanometer. So the galvanometer deflects when the magnet is inserted into the coil and then returns to 0. So when the magnet is moving up or down through the coil, the galvanometer will deflect, and when this north and south pole is stopped in between the coil, the galvanometer will return to 0 point. Then part 2 states state any effect on the magnetic field produced by the coil. It produces the magnetic field on the S pole at the bottom. So this will create a magnetic field at the S pole of the magnet. So this is what will happen in part 2. 10 is there's an undercharged conducting metal plate rests on an insulating support. Figure 10.1 shows the plate and the positively charged insulating plastic sheet placed on top of the metal plate. So part 1 state describes the flow of charge that takes place when the plastic sheet is placed onto the metal plate. So the negative charges move upwards towards the plastic sheet. Part 2 states on figure 10.1 show how charges are now arranged within the metal plate. So in metal plate, positive charges will move towards the negative plate, and it will be closed over here as I stated, drawn over here plus all across the metal plate. Then part 3 states, state and explain if this arrangement of charge helps to keep the plastic sheet in place. Yes, it will keep the plastic sheet in place because unlike charges attract metal plate and the plastic sheet. So this is what we'll write in part 3. Then question B states, figure 10.2 shows two uncharged conducting spheres suspended on insulating threads. So these are two uncharged spheres on insulating threads. 1 states the spheres are now both given positive charges. Draw a possible solution of each sphere and thread. So when these are both positively charged, the positive charges repel and they will move away from each other. So this is the new position of the sphere and the thread with positive charge labeled in it. Then part 2 states, explain the position you have drawn. Same charges repel each other, so they will move away from each other. Question 11 is states a radioactive nucleus of uranium-235 decays to a nucleus of thorium and emits an alpha particle. Complete the equation. So over here the uranium-235 has 235 as total number of protons and neutrons, and 92 as number of neutrons. So over here if we have 4 at top, so 235 minus 4 will be 231, and then at bottom we have 2, so 92 minus 2 will be 90, so 231 over 90 thorium. Then part B states a nucleus of uranium-235 undergoes nuclear fission in a reactor state. What is meant by nuclear fission? Splitting of nucleus into two parts is called nuclear fission. Part 2 states explain why a nuclear reactor is surrounded by a thick concrete wall. Fission involves production of radiations which are dangerous to humans, so thick concrete walls stop the radiation and protect workers. Then part 3 state one environmental advantage and one environmental disadvantage of using a fission reactor to generate electrical energy in power station. Advantage is greenhouse gases such as CO2 or SO2 are not produced. Disadvantage is there is a risk of radiation in case of accidents. So this is what we'll write in part 3. Then question C states the thorium produced by the decay in A is also radioactive and has a half-life of 26. So if the half-life is of 26 and at certain time a pure sample of isotope initially contains 48 multiplied by 10 to the power of 9 atoms, calculate the number of atoms of this sample that decay in the following 52 hours. So if at 26 hours we have 48 multiplied by 10 to the power of 9, so at 52 we have 9.6 multiplied by 10 to the power of 9. So at 13 it is half of 4.8, so 2.4 to 10 to the power of 9, and at 6.5 it is 1.2 times 10 to the power of 9. So at certain time it states calculate the number of atoms of this sample that decay in following 52 hours. So first half-life is 26, then second is 30, and third is 6.5. So we'll calculate the difference between the second half-life and the fourth half-life. So 26 is 4.8 multiplied by 10 to the power of 9 minus 1.2 multiplied by 10 to the power of 9, which will be 3.6 multiplied by 10 to the power of 9. So the number of atoms is 3.6 multiplied by 10 to the power of 9. And this will be the final answer for question C.